Okay. I apologize for the technical issues there, but we will get started. So just as a quick recap of containerization, I'm going to quickly just go over the steps to containerize this app that I've made. This is the same code as demo 4, like last time, and I will be quickly containerizing that. So in the meantime, if you'd like to set up the Google Cloud stuff, you're free to do that. Otherwise, if you haven't done this yet, it's also part of your assignment, so you can just follow along. So let's make a Dockerfile. Let's have our Python 3.7 image. Let's create our directory user.app. Let's set the working directory to be user.app as well. Let's copy everything we have in our current directory. We'll pip install. And we will run Python app.py. And then the docker-compose file, right? We're going to have our version to be 3 and our services to be, I'm going to call this demo. Let's make the image demo 6. And ports will be 5,000 to 5,000. So this is the same thing as last lecture. Again, what we're doing here is we're telling the computer how to get started with running our app. And then we're telling here what images to run and how in like containers. OK. So the thing that you may not have seen and is new, going to be new this week, is to create a docker-ignore file. So Kate actually included this in the last demo, but it wasn't part of your assignment. So in case you missed it, you can docker-ignore, make a file called docker-ignore. And what this does is when it sees a file that's listed within docker-ignore, it won't actually push it to Docker. So the reason why this is important is because, like we've grilled you about for this entire semester, we don't want to be including our virtual environments in anything that we submit or anything that we push onto our computer or onto the cloud. We don't want our PyCache, right? And we don't want our DB file. So I'll be including that in the docker-ignore file so that it doesn't actually get pushed to Docker as an image. Now, let's go back to my very messed up SSH terminal and docker build. I need to change into my source folder. Docker build -t, that's Najima demo 6, and we'll tag it with the version 1.0.0. So hopefully all this is pretty familiar to you except for the docker-ignore stuff. But yeah, so let's do that. Cool. So I should wrap up pretty soon. OK, then we can push this to Docker Hub by doing docker push and then the name of our image. OK, so while we wait for this to happen, let's get started with the actual crux of our demo, so the deployment part. So again, this is the page I was referring to. And if you'd like, you can start your free trial by clicking on this link. I'm already signed in, but you can start your free trial by just clicking on this button right here. OK, so apparently I'm not signed in. Oh, I am signed in. Go to console. So yeah, is anyone trying to get this set up, or can I move on? Show of hands if anyone's trying to set up. OK, we're good. Cool. OK. So before we get started with the demo for today, again, the whole point of deployment is to make it so that everyone in the entire world can access our apps, right? So this URL right here, oops, that's not zooming in on the URL. This URL right here, which says 34, I don't know if you can see it. Type it into my terminal. That URL right there, you can actually all go on your computers and your phones and look at the tasks that I've made on my to-do file. So this is what we'll be doing for today's demo, and on Wednesday's demo, we'll be making it so that our apps are all publicly accessible to the web. Cool, and this is amazing, right? Because we can get our computers to connect to it, we can get our mom's computers to connect to it, we can get our phones to connect to it, we can get our TI Inspires to connect to it, we can get our Bluetooth Blueberries to connect to it, our Nokia phones, whatever, that has access to the internet can connect to it, and it'll see the exact same thing. Also, if this isn't exactly what you see, it might be because I have an extension called JSON Viewer, which is going to be pretty nice for seeing anything on the web. So if you're on Google Chrome, I highly recommend you download that. Okay, so let's get started. This is the landing screen that we see on Google Cloud. I was practicing earlier, but we can get a new project started by just clicking on the project button, or this, it'll say new project here, and then you can click on new project right here. Let's call it demo 6. And this will say cornell.edu for all of you. My Cornell account was being kind of weird, so I'm using my personal account, but this location and organization will both say cornell.edu for all of you. So let's create a new project. And if you click on this, we are now in our newly created project. Awesome. So now the next thing we have to do is create a virtual machine. And the reason why we do this is because, as you all know, we need some sort of machine running our app. A server is just another one of those computers, another one of those machines. So we have to rent a server from Google. And the way we do that is by scrolling down and hovering over compute engine. And under virtual machines, we can borrow a virtual machine instance. So let's click on that. And when we click on this, it'll tell us to enable this API. You can just go ahead and click enable here. This will allow us to create a new virtual machine. And there'll be a bit of waiting here and there. Okay, awesome. It just finished, finally. Okay, so now I think we should be able to click on compute engine, VM instances, and voila. Now we're given a list of virtual machine instances that we have. Obviously, we don't have one because we haven't created one yet, but we will go ahead and create an instance. So let's do that. And we'll call this instance the name of the machine we want to, well, we can call it whatever we want. I'm just going to go ahead and call it demo 6 as well. Demo 6-VM for virtual machine. And we can change the region as well of where it's going to be hosted. Generally, I think it's just a nice practice to choose a location that's close to you. So I'm going to go ahead and choose, I think Toronto's closer to us than Montreal. But yeah, US East, Northeast. And we will make a general purpose virtual machine. You don't particularly have to know what that means. And yeah, also here, like this stuff isn't too important. I guess the one thing that's important here to note is that each of these computers come at a different price. And some computers are more powerful than others. Obviously, our apps are very, very low. It's not very heavy lifting. So we can just choose. I'm just going to be safe and choose a small version. You should have plenty of funds to have this running for like literally months with your $300 of Google Cloud credit that you'll receive later. So you don't have to worry about it too much. If you want to up it, you can. We can ignore a lot of this stuff. The boot disk is pretty important. So this is what we'll be changing this soon. The boot disk basically tells you what machine is going to be running, like what operating system is going to be running. So we'll change this from Debian and we'll choose Ubuntu. And all this is fine. Yeah, we'll just be using an Ubuntu machine because It's one of the more commonly used machines in both industry and in our app, in our organization. And the last thing we'll change is this firewall. So the firewall basically tells you what traffic do I actually accept, right? So if I make an HTTP request to my server, I want to be able to access it. By default, it lets you not access it, in case of like malicious attacks. But for the purpose of our class, we're just going to be allowing all HTTP traffic, and you can just do that by ticking this checkbox right here. So that's all we have to do. Let's create this virtual machine. And the way we can verify that this virtual machine was successfully created is just when a check mark shows up right here. So yeah, now we've successfully rented a computer from Google. Let's go. We've hacked into Google. And wait for that to boot up. Awesome. Okay. Now we actually want to be using this computer, right? We actually want to run our apps on this computer. And the way we access our computer is, like Kate mentioned in lecture, is to SSH into it. So generally, you'd have to use a bunch of terminal commands and make like the secrets thing and whatever. But for the sake of this course, we're going to make it simple. We chose Google Cloud for partially this reason as well. And you can just click on this SSH button right here. So this will take you to the terminal of your newly borrowed computer, which is super cool. So what this means is that you've basically given yourself access to a different machine that isn't actually on your computer. So I can do ls list, right, to list everything in this directory, and there'll be nothing there. This is an entirely different computer, again, from our own computers. So hence the name virtual machine. So hopefully you guys keep that in mind. Okay, so how do we actually get our app.py to be running on this newly borrowed computer of ours? Well, again, Docker is extremely, extremely useful in our scenario because Docker allows us to just simply run docker-compose up to run an app, as opposed to having to pip install and python app.py and whatever. So we have to install Docker. So the way we do that is kind of tedious. On our textbook, there's two links over here, and you can click on both of them. And there'll just be a bunch of commands to run to install Docker. So step one is the only step you're going to have to follow for both of them. The rest is optional. So let's just do that. So since I don't think a lot of you are doing this live, I'm just going to speed through this. That. Oh, I need to press that. This is not something you should be seeing. Okay, and you'll have like a few confirmation messages. You can just hit yes for all of these. So let's run each of these. Okay, and then yeah, so you can probably tell that a lot of deployment is going to just be following steps that you know how to do. There's actually a way to automate a lot of this, and we won't be covering that in lecture, but you can already start seeing how kind of tedious this gets when you want to be running multiple apps. But for the sake of just introducing deployment to you guys, we'll be running all these commands. Okay, now if we type Docker, you can see that we have successfully installed Docker because it doesn't tell us, hey, I don't understand this command. Nice. So now let's download Docker Compose. And this shouldn't take particularly that long either. Amazing. So we have Docker Compose and Docker successfully installed. Okay. Now that we have Docker and Docker Compose installed, we can create a docker-compose.yml file in our root directory. So that's going to look identical to the one we created here, because the way we want to be running our app isn't going to be any different on any other computer, right? So the way we can do this is just copy everything we have in here. And then we go to our terminal of our new computer, and we type vim, and then the name of the file. So vim is actually a text editor. You've probably all been using either Atom or VS Code, but vim is it was like a built-in text editor within your terminal. And the way the syntax of vim works is if you do vim and then a file name, you will newly create that file name if it doesn't exist. But if it does exist, you'll just edit an existing file of that name. So I'll just create a new file called docker-compose.yml. And now I've created a new Docker Compose file, and I will be inserting everything that I have in here into it. So the way I can do that is by hitting I for insert. And you can see on the bottom left here that I've entered this insert mode. Again, a lot of this is going to be pretty memory based, so you might have to like rewatch this several times to fully understand it. But hopefully that's not going to be too difficult for you guys. Okay, so now I just command V, like I always would for pasting, and I was able to successfully paste it. The one thing we have to change here is instead of 5,000 to 5,000, we want to be changing this to 80 to 5,000. And the reason for this is because, again, the first number is the port within your terminal, and the second number is the port within the container. So the reason why we're choosing 80 here is because HTTP requests by default all map to port 80. Recall how for PAs 1 through 4, you all had to type in localhost :5000. Do we type in google.com : some number? No, it's overly verbose. We don't want to be doing that. So we'll just take the default value of HTTP being 80 and map it to the 5,000 within our container. Does that make sense? Few nods. Okay. So this way we don't actually, if you remember my example earlier, we don't have a : some number, right? So that's because of this. So let's change that to 80 and let's save this. And the way you save it is by hitting escape. And now that the insert thing is gone from the bottom left here, we can type in : WQ. This is for writing and quitting. Writing is saving and quitting is just quitting out of this file. Amazing. Now, if I do ls, I've successfully made a Docker Compose file in this directory. Okay, and then let's see. Now we can do docker pull, and then the name of the demo that we just pushed to Docker Hub. So let's see if that actually successfully pushed. Did I even look at this? Okay, it looks like it pushed. So we can pull that version of the Docker image that I created by doing docker pull snajima demo 6 : version 1.0.0. Oh, okay. The thing that y'all have to note, and I'll probably also be forgetting several times, is when you run Docker, you're gonna have to type sudo in front of it. This just means give me all admin privileges to run this command. Generally, you wouldn't want to be doing sudo every single time. So there is actually an optional step that you can run potentially tomorrow once we get the Google Cloud credits to allow you to run Docker commands without the sudo word. But for now, I'll just be writing sudo in front of all Docker commands. So let's docker pull our image that we newly pushed to Docker Hub. And awesome. So now we've successfully pulled our images. Again, we can list all the images we have with Docker images. Oh my God, sudo docker images. And we can see that we successfully pulled the image that was in our local computer and now is all of a sudden on our newly rented laptop or computer, sorry, not a laptop, Docker images, right? So we have this one that we created on a local computer and is now on this server's computer. Finally, and this is what we'll end on today, we can, just like, with running our Docker compose file on our local machines, we can run sudo docker compose up-d. Demo 6. Oh, okay. I haven't tagged it with latest. So hold on. So Docker tag Najima demo 6 v 1.0.0, and we can tag it with demo 6 v1 or latest. Okay, now we have the latest tag, and now we should be able to Docker compose. Okay, awesome. Sorry, I'm going to keep you guys a bit longer, but yeah, now I successfully Docker composed our live instance of our app. So if we do docker ps, sudo docker ps, we have the live instance of our app running. Amazing. Now let's go back to our virtual machine instances. And you can see that we have two IPs here, the internal IP and the external IP. The external IP is the one that everyone on the internet is going to be accessing. So if we actually hit this and open this up here, right here, you can see that you can also do this, by the way. You can see that we've successfully created a live instance of our app on the cloud, right? Anyone can access this, which is fantastic. Now the front end can use it and so on. So hopefully that wasn't too rushed. That'll be it for demo for today. We'll carry on Wednesday. But yeah, that's going to be how to deploy on Google Cloud. Any questions before we move on to Kahoot? Did that make sense? Okay. Oh my, that's not the right tab. Did that again. We have the computer sounds. Sorry? Yeah. Also, one exciting thing, I don't know if all of you have seen this, but we have a running Kahoot leaderboard that's been going on for this entire semester. And yeah, we're gonna cut off the last day to take attendance to partake in this competition to be lecture and demo 8. So this week is lecture 6 for deployment. Next week is gonna be authentication. And the week after that is gonna be images. That will be the last week. We'll be tracking attendance and we'll have 5 prizes to be giving out to the top 5 people on the Kahoots. Okay, show of hands, who's not in? Wait for another minute or two. Who's not in now? No one? Okay, let's get started. Nice. Oh, wow. That's actually really good. Yeah. So obviously Docker Hub is amazing because we can run containers extremely easily by just typing docker compose up, right? Let's move on. This is a movie reference. I don't know if you guys watched this movie, but it was kind of jank and weird. I think it's aired like last year. But there was this scene where this guy was axing the servers of this video game, and the video game was like slowly dying, but clearly that's not how it works. And yeah, a server is just another computer that we run our code on. Yeah, so again, SSH-ing is our way to connect to the server's computer, right? Generally, we only have access to the terminal, which is why it's very critical for y'all to just get used to using the terminal over your years in just doing CS in general. You're not going to be able to have like your whole UI with like, a Finder or like file browser and whatever. So yeah, SSH is our way of connecting to servers. Oh yeah, I'm giving you all 30 seconds for these next two questions because I thought they'd be a bit harder, but I guess not. Yeah, you guys are amazing. Clustering is allocating different tasks to different servers. That way, if one of them goes down, right, then our whole app doesn't crash. So Kate explained this very well in lecture. So yeah, hopefully that made sense to all of you. Another 30-second question, but this is very conceptually important to know, especially if you're interested in going into software engineering. And yes, load balancing is to allocate tasks to multiple servers so that not all servers will have too much work to do. All right, congrats. Thanks for coming to lecture, everyone. All right, so let's get started. A little announcement. Unfortunately, we still haven't gotten the Google Cloud credits for you guys. I've been begging our faculty advisor to give this to us as soon as possible, but unfortunately, he hasn't come around yet, or like Google hasn't come around yet. So we might extend the deadline for this assignment if absolutely necessary. But yeah, today, for the most part, I think you guys will have to just watch along and kind of rewatch the demo and figure it out from there when you start the assignment. So hopefully, fingers crossed, we'll get those soon. Okay, so let's just quickly cover what we talked about last time. So we started off by starting with our demo 4 and creating the Dockerfile from what we learned from demo 5, and a Docker compose file, and a newly created file called dockerignore. This will be part of your assignment for PA6. So make sure you review this if you have forgotten. Then what we've done is we've built our image, and then we've pushed it onto Docker Hub. And then we went onto Google Cloud, and we created a project. And from that project, we created a virtual machine, right? Is a computer we borrow from Google. And then on the virtual machine, we've actually installed Docker, and we pulled the image from Docker, and then we've ran it. So this external IP is something that is publicly accessible, and it will return the base endpoint and any endpoint that we decide to hit. So this is actually, again, publicly accessible to you guys. If you go to this URL, you can probably see this exact same thing. Cool. Any clarifying questions from last time? Are we good to move on? Okay, so let's get started for today. Cool. So we have this URL, and clearly it's successfully returning us the tasks that we have in our base endpoint. Now, let's actually test this on Postman. Do the other endpoints work? So let's try and see if the other endpoints work. So I'll actually duplicate this collection. Let's call it demo 6. And we can replace this localhost 5000 with now our URL from our deployed server. Cool. So just as expected, our endpoint is successfully hit, and we get our expected response. We can do all the other methods that we've checked out so far as well. So we can create a new task, right? And now if I actually refresh on our browser, you can see that this task was actually successfully added. Okay, so the Postman, so this URL is clearly working, and it works for you guys as well, which is the whole point of deployment. One cool trick about Postman that I'll quickly cover is this number is very annoying to type every single time we want to be testing our endpoint. So one cool trick you can do is create an environment variable, but within Postman. So the way you do that is by clicking on this little eye icon on the top right, clicking on add under globals. So we're setting global environment variables. And let's call this variable name server URL or something, underscore URL. And we can give it the value that is our server's address. Let's save this. And now, this is really cool. Instead of this, we can do double nested curly braces, type in the name of our environment variable, so server underscore URL, and boom. So now we don't have to type in that number every single time. So this is a cool little trick that you're going to be using for PA6, since our server URLs are going to be a bunch of numbers. If you'd like, you can purchase a domain, but we're not going to be doing that because that costs money. Okay. Awesome. So now that we've done that, let's discuss how we can redeploy a server. So what this means is, if let's say I make a change to my code, how can I actually make that change be reflected on the server's computer? So let's make a quick change. Let's just go to app.py, and let's go to our base endpoint and make a function called hello world, where all it does, and we can just return the string hello world, right? Let's save that. And now this is saved. Now, obviously, if I go back to my server and I refresh this, that change is not reflected. I'm on the base endpoint, right? But it's not actually sending me hello world. So we actually have to push these changes to the server. So the server's version of app.py is exactly this version of app.py. So let's discuss how we can do that. So obviously, right, instead of using GitHub or something like that, we'll be using Docker Hub and Docker images, because it's so convenient to just be able to run docker compose up, as opposed to having to, pull the code and then run app.py and blah, blah, blah. So let's build our image. Tag it. Let's make sure what I called them last time. I called it demo 6. So docker build-t demo 6. Give this version a 1.0.1, and we'll build from this very directory. And while we wait for this, Docker Hub, so hub.docker.com. And in a little, we have demo 6. You can see the tags. And once we finish building this image, and we push it to Docker Hub 6 version 1.0.1, right? Since we called this version 1.0.1 as opposed to 1.0.0, which was our first version, now that it's pushed, we can go to our Docker Hub repository, and if we refresh it, you can see that now we have 2 versions of the app that we created. So this is one way of distinguishing versions of your app that you're running. So this is why, right, if you go to the Python Docker image, you'll find 3.8, you'll find 3.7, and so on. So that's how they've done it. Cool. So now that we have a version 1.0.1 that we want on our server, we can SSH into it, right? Is to connect into the server once again. And let's zoom in once this loads. So this is our server's computer once again. So let's just check the containers that are running. Sudo. Right, and we have this container that, right, up 47 hours ago that we actually built last time. So we want to be replacing this container with our new version of our container. So again, to kill a Docker container, we can run docker-compose down. So this will now stop the container that we ran last time, that we started running last time. And so now once this finishes, you can see that if I refresh this, I can no longer reach the site because the Docker container is no longer running on our borrowed laptop computer. So let's go to our SSH terminal and let's Docker pull the image that we newly created. So now we've downloaded the 1.0.1 version of our image, and you can tag it with the latest version by calling it latest. Keep forgetting to type docker or sudo. And now if we do sudo docker images, you can see that the newly created version 1.0.1 is the same image as the latest version of our running app. And now, if we do docker compose up again, we can go back to our, the same URL. If you hit it, you can see that the hello world endpoint is now reflected. Cool. Okay. So does this make sense so far? We just pulled the image from Docker and reran it, right? Does that make sense? Okay, awesome. Now let's go to our tasks endpoint. This is the endpoint that showed us all the tasks from the last lecture. Now, notice how the task that I added from earlier, beat Justin at Smash, is no longer there, right? Our data didn't persist. What is going on? The reason why this is happening is because, again, all our code and our processes run in or live in our Docker container. Our Docker container doesn't actually have a DB file. And the reason for that is because we Docker ignored it, right? So the Docker image doesn't actually have a DB file. It's just every time you actually run the app, it creates a new one. And we don't want that. We want the data to stay persistent. So what is the workaround around this? Well, instead of having the DB file live in our image, right? Because that wouldn't really make much sense. Like I would have a version of the DB file here, and if I uploaded it to the server's version of the DB file would get overridden. So the way we do this is instead of having it live in our Docker container, we can have it live in the server's directory. In the server's directory, we currently just have a docker-compose.yml, but we will be adding that DB file shortly. So let's talk about how we can do this, right? We can do this by making a thing called a volume. A volume is something that's very useful for persisting data. And the way we can define a volume is by going into our docker-compose file. So let's vim into our docker-compose.yml. Actually, before we do that, I want to know what this current directory is, the file path to this current directory. Again, this is why it's so critical that you guys get used to using the terminal and using terminal commands. So the way you check your current directory is pwd, short for print working directory. And this is actually the directory that I'm currently in. You can actually do this on your local computer as well. And you can see that I am currently in my documents folder, in this semester, in the intro to backend folder, blah, 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 blah. So that's the same idea here. I'm just printing where I currently am. With this in mind, I'm actually going to go ahead and copy this. Let's go to change or edit our Docker Compose file. And let's add a volume. So volume is, again, a mapping of a file from outside the container to inside the container. This way, the file actually lives outside the container and hence stays persistent. So the way we do that is by mapping it from outside the container, right? This is the directory we're currently in, and we want to make a todo.db file there. And we'll map it to the DB file that's inside our container. And again, the working directory for what's inside the container is defined in the Dockerfile. Our working directory within the container is user/app. So I'll go ahead and copy this, and I'll map it. So the way we map it, just like we map the ports, is with a colon. And then it will be /user/app/todo.db. Now, I know this is probably very hard to wrap your head around initially. But again, to reiterate, the thing we're doing is we're creating a DB file outside of the container so that it stays persistent. We're mapping that DB file to inside the container. Hopefully that's clear. Feel free to rewatch this part as many times as you'd like to wrap your head around it. And this is our way of having persistent data. So if you'd like to have persistent data in any other form other than a DB, you can do it with this volume thing here. Oh, actually, it's plural. It's volumes. Sorry about that. But yeah, so this is how you map a file from outside the container to inside the container. Cool. OK, so let's now Docker Compose down now that we've changed some things about our Docker Compose file. Let's rerun the server. And do sudo docker compose up. Awesome. Now, if you look at our current directory, you can see that this todo.db file was newly created. This is the persistent file that we've newly created by defining it in our Docker Compose file. So now that this todo.db file is in our directory as opposed to our container, which obviously we update by pulling it from the Docker image. If you refresh this, hey guys, sorry for the little hiccup in lecture today with demo. It turns out I was missing literally one terminal command that I had to run, and it kind of messed everything up. But I'm here to re-record it and make things right, and make sure that you guys end off the deployment with a good note. So just to quickly recap what we had, what the issue was. I tried to Docker Compose up after defining volumes, which I'll actually just shortly talk about. But what that ended up doing was if I list the current directory, everything in the current directory, you'll see that I have my Docker Compose file and a todo.db file. Now, I thought this was a todo.db file, but you can notice here that it's in a different color. It's light blue and it's bolded. This syntax actually means in Google Cloud's terminal that this is actually a directory. It's not actually a file. So that was actually causing issues because as you all know, so far with all our database files, they've all been files, right? They haven't been directories or folders. So let's fix this. The way you can fix this is first by getting rid of this. Well, we're not in a Finder or a Windows equivalent of a Finder, So how would we actually go about removing this this folder? Great opportunity for you guys to learn another command on the terminal. So hopefully you guys retain this, but to remove anything in your current directory or any directory for that matter, you can use the command rm and the name of the file. Now, doing this directly doesn't work because todo.db is actually a directory. It's a folder. The way you can delete a folder is by specifying the -r flag, short for recursively. So just to recursively delete everything in that folder. And if you do that, it will successfully delete it. And if I do ls now, I'll be left with only my docker-compose.yml file. Awesome. So now that that's cleared, let's actually make our DB file right correctly this time. And the way we can do that is by using the keyword touch. So I mentioned this several times, especially in my optional Git lecture, but touch is a keyword to create a new file of that name. So this can be anything from text files to .db files. You know, in our situation, obviously we're going to be making a todo.db file. So let's do that. And now if we do ls, you can see that we have our docker compose and our todo.db file. Great. Now that that's out of the way, let's finally sudo docker compose up. And you can see now, if I hit refresh here, we can actually access our tasks. So I just want to quickly demonstrate why we needed to do the hold volume thing in the first place. Let's hit an endpoint in Postman. So let's create a new task. All right, let's use that trick that I just showed. Where we go. And let's create a task. Let's just do the one I used in demo 4. All right, and if we go back to our browser or in Postman, doesn't really matter. And you can see that that new task was successfully added. Cool. So now let's make a change to our app.py and redeploy our app. So maybe instead of, right, this was actually after demo, but maybe instead of hello world or hello my name, we want to do hello Tawny. This is cool. Cool. Now that we've done that, let's actually build a container out of this. So we can do docker, oops, let's be in the correct folder for that. Awesome. And let's do docker build -t demo 6. And this is after demo. So the version is going to be 1.0.3 since I already made it 0.2 in demo. And dot for building it from the current directory. And let's push it like usual. SSH-ing 6. And finally, let's go to our servers repository and pull it. So let's first bring down our container because we want to be running our updated version of our app. And let's pull the one that we just created, which is version 1.0.3. And let's specify. Also a great question on Ed. The reason why we keep tagging this is because in docker-compose.yml, we just specify that our image name is /demo6. Docker by default, if you don't specify an image tag, it'll just use the latest version. So we have to tag this one with the literal string latest. Images, you can see that the latest version is our 1.0.3. Now, if you don't actually have to be putting these Docker tags when you build these images, but that means that each of your Docker images will be overridden and be labeled the latest every time you build it. So if you don't want that, you can have versions like these. Cool. Now let's docker compose up -d. And now I think I'm going to leave this part in demo where I demonstrated that the data doesn't persist if we have our DB file living inside our container. But now that we have it outside our container, hopefully this task should stay. So let's refresh it and check it out. Amazing, it stayed. So this is how we make sure that data stays persistent through the use of what's called Docker volumes. So hopefully that's clear, and sorry for the little mishap during lecture, but hopefully this clears things out and everything makes sense. Yeah. Okay, but in the meantime, let's discuss what we're gonna do next. So I'll probably make like a re-recording on how this works if I still can't figure it out by the end of lecture. But essentially the idea is that by defining a volume, you can map a file from outside the container to inside the container. And that way, the file will always live outside the container and hence will never be changed by pulling and pushing and updating Docker images. Okay, so with that now out of the way, let's talk about environment variables. So this is going to be very, very important, not within this class, but after you leave to the realm of software engineering, or if you ever want to join app dev, or if you want to work on a personal project with external tools, environment variables are going to be very, very important. And the reason for this is because we don't want secret values being exposed to the internet. We don't want secret values being actually uploaded onto GitHub. So the workaround around something like this is by making this file called a .env file, which is where our environment variables live. And the way we can define environment variables is just by mapping a key, so the variable name, let's call this netid, and the value. So my netid is SN685. And for whatever reason, let's say this netid is extremely private and I don't want anyone on the internet to see it. A lot of the time, this will be not netids, but rather something like passwords or something like keys, so you can access a resource from an external tool. But yeah, that's what environment variables are. So the way we use an environment variable in our app.py, let's say instead of hello world, we want to return hello SN685. Actually, let's change this to my name, because I'd like to be greeted by my name and not my netid. So instead of typing in hello Shengo, which if for whatever reason is very personal and private, we can replace this part of our code with environment variables. The way we do that is by doing os.environ for environment .get and then the name of the environment variable, which is name. Now this os is red squiggly line because we haven't actually imported this library, so we can just do that up here like such, import os. It will be squiggly for you guys if you haven't done this yet. This is only squiggly for me because I have bad Python syntax, because I don't have a plus here to combine these strings. Let's do that. And then you can see now my hello world endpoint is saying hello, reading the environment variable with the variable name, and then adding an exclamation mark at the end. So let's actually test this on Postman, like locally. So we can do Python 3 app.py. Wait, I actually might have, okay. And let's go to Postman. Let's go to demo 4. Actually, no, it's not. Yeah, we can do demo 4. And get base endpoint, and we'll do localhost 5000 /. So this is the base endpoint, right? We don't have anything after the slash. So it's just a slash. And now if we do this, oh, actually, this won't work. Okay, sorry. I forgot to clarify that you have to specify that you're going to be using this environment variable file somewhere. And that somewhere is going to be in our docker-compose file. So in our docker-compose file, right now we have the image name, and then we have the port that it's mapping from outside the container to within. We can define the environment variable file to use with the value env_file, and specifying the env file that we called .env. So it's already suggesting that I do that. So let's call it .env, right? And this is our docker-compose file. So the way we're going to be running this isn't Python app.py, but rather docker-compose up. So we'll do docker-compose.yml. Docker build -t -6 /6, and we'll tag it with the version 1.0.2 and build that image. Yeah, so again, this is like pretty easy, and clearly it's slipped my mind several times as well. But whenever you make changes to the Docker file or the Docker compose file, it's important that you guys rebuild that image, because the changes aren't reflected on the image. The image are, again, just blueprints for our code. Now we can Docker tag our new version with, and we'll do docker compose up-d. And now this should work. Yeah, awesome. So this is now a live instance of our app. So if you go to Postman, and if I hit enter, you can see that now it prints hello Shango, right? And the reason why this is so nice is because I didn't actually have to type in my name. I just had to type that I'm referencing an environment variable called name. This file right here, .env, never uploaded to the internet. This environment variable file is where all your passwords and all your secure strings are going to be contained. So we don't want to be pushing it to Git. We don't want to be pushing it to Docker. So if you have a dockerignore, you would add it here. And if you have a gitignore, which you'll be using for hack challenge, and if you ever want to use an external API. So does this make sense so far? Any questions? Are we good? Is it also clear that like how useful Docker is now? All we have to do is build the image and Docker compose up, right? If we're using if we're working on a Python app, or we're working on a TypeScript app, and we're working on a Java app or something, we don't actually have to remember the commands to run each of these things. We can just build the image and run the image. So that's what's so convenient about Docker. Okay, awesome. Now that we've done that, let's check the images that we have. And we have the version 1.0.2 that we just created, our earlier version from lecture today, and the version 1.0.1, which is from last lecture. So let's docker push s-najima 6 and the version 1.0.2. And if this successfully works, we can go to the Docker Hub, refresh, and you can see, as did last time, we have our new version of our Docker image. Okay, now let's go to the server, and we will Docker pull that new image. So 6 version 1.2. And we'll tag this newly created or newly pulled with version 1.0.2. Now if we do Docker images, we have our 3 versions that we've installed, and the latest one is the same as the newly created version that we have. Okay, so let's try Docker compose up. And see what happens here. Actually, did I forget to Docker compose down? I did. Docker, yes. We don't have any containers running, so we will compose up. And now let's try to hit this base endpoint. We wanted to print hello Shango, right? Oh no, what just happened? It's not printing hello Shango. Does every other endpoint work? It does. So the error is actually because we didn't push the .env file to Docker, right? The .env file stays on our computer at all times because we don't want it to be in the internet and other people to be seeing the secret values that we have. So the way we actually work around this is just to create a .env file on our server's computer. So to clarify, once again, .env files should ever only exist on your server and on your computer. Nowhere else. We don't want other people seeing these secret values. So let's vim.env, right? Vim creates a new file if that file name doesn't exist. If it does, it'll just allow you to update the existing file. And let's basically copy the contents of .env here into Vim. I to insert, right? If I hit I, it'll show me that I'm in insert mode on the bottom left, and I can just paste it. And the way I save and exit out of this file is by doing :wq. Also, sorry that name thing is a bit hard to see, but it's the same thing as what's in my .env file locally. So we've saved that, and we can do sudo docker compose down. And then sudo docker compose up-d. And you can see that this is still actually not going to work. So there's two things. I only demonstrated messing up twice because it's important to update both of these files. We updated our app.py to have os.environ.get and then the name of the environment variable. We updated our .env file on our server to contain the secret value we want to have to update the Docker compose file. So the Docker compose file on the server is not the same as the Docker compose file locally. Like, it's not going to be updated when you pull the image. So we have to manually change that as well. So let's vim and change this to contain file equals .env. Oops, .env. So this is the contents of our Docker compose file. Now, if we docker compose down and rerun docker compose up, you can see we have finally successfully made the .env file on our remote server, defined it in app.py, and then change our docker compose such that it actually reads from this environment variable file. Okay. But that's actually it for demo this week. The crux of it is that, right, we want to make sure that Docker is accessible, or sorry, our server and our app is accessible to anyone who's using it from the outside. And the way we do it is using a combination of Docker and SSH-ing into the server and everything we've learned so far. So before we start the Kahoot, just as a little fun activity, you guys can try to hit this endpoint on your Postman if you have your laptops open and make a task. Please do not put anything appropriate or inappropriate, so we can keep doing fun things like this in future semesters. But yeah, just try making a task, and we'll, I don't know, give like 5 minutes for people to do that, and we can see what fun things people have to do in the remainders of their semester or day, and then we'll get started with the Kahoot, and we'll call it early for today. It's a post request to this URL right here. While we wait for people to do that, does anyone have any questions about deployment, or is it clear? Are we all good? Did everything make sense? Hopefully everything made sense. Okay, who still wants to add tasks? Are we, okay. Thank you, Kate, my co-instructor. Who still wants to add tasks? All right, let's refresh it. Let's see what abomination you guys have created. Whoa, what is that? Oh my gosh. What is this? What is this? Some like gang sign? Oh my God, there's so many of those. Be sussy. False. It's your boy Darren. Thank you, Darren. Cry. This is a common one for all of us, huh? Oh, what is all this? A lot of those too. PCE. What does that mean? Am I tripping? I don't know. Oh, okay, that was it. Okay, hopefully that was entertaining for you guys. Let's just check one more time if anyone's added anything. Bruh, and another bruh. Awesome. Okay, so hopefully that was fun. A little last activity to end our course series. Starting next week, we're going to be covering authentication, so logging in, right? How logging in works in the backend. And then the week after that is saving images. So we actually haven't covered how we save images in a database, but that will be the week after that. So stay hyped. We'll start the Kahoot.